Hello guys, in this video we're gonna talk about water pollution. Before that, let's introduce our team member.
Water pollution occurs when harmful substances, often chemicals or microorganisms, contaminate a stream, river, lake, ocean or other body of water, degrading water quality and rendering it toxic to human or the environment. There are several types of water pollution, such as chemical pollution, natural pollution and thermal pollution. In this video, we're going to discuss about nutrient pollution. In more specific, we're going to discuss about high calcium level in water. While calcium can provide health benefit in low quantity, it is one of the various dissolved minerals that make water hard. That hard water wreak havoc on piping and plumbing over time, especially in wastewater treatment application.
High calcium level in water, also known as hard water. It can be caused by several factors. There are three possible contributors. The first one is geological factor. When rainwater or groundwater move to limestone calcium that containing mineral, it can leading to high calcium concentration in the water. Areas with limestone or other calcium rich geological formation are more likely to have high calcium level in their water. Second one is evaporation. In places when water evaporation rates are high, the remaining water may become more concentrated in dissolved minerals like calcium. As the water evaporates, minerals in the water remain behind, increasing the hardness over time. This is particularly noticeable in lake or groundwater sources. The third one is human activities. Certain agricultural and industrial activities can contribute to increase calcium level in water. For example, the use of lime in farming to neutralize soil acidity can result in runoff, carrying calcium into nearby water bodies. Similarly, industrial process such as cement production can release calcium compound into the environment, eventually increasing calcium level in nearby rivers or groundwater. Each of these factors contribute in different ways depending on the local geography, climate and human influence, but all lead to elevated calcium concentration in water source.
To support our discussion, we have proposed one experiment that can be conducted to evaluate the severity of high calcium level in water. Material and equipment used in the experiment. Number 1, water sample that contain calcium ions. Number 2, reagent 10. It is liquid soap to maintain pH level. Number 3, reagent 12. It is indicator solution. Number 4, reagent 11L. It is titrant. And the last one is number 5, 100 ml glass container. We go to procedure. First one is add about 25 mm water sample that contains calcium ions Ca2+, which contribute to the water's hardness. The second one is add 2 until 3 ml of reagent 12. It used to indicate the presence of calcium ions by changing color. The water sample should initially turn red because of the interaction between the indicator and the calcium ions. Next, add 5 ml of reagent 10. Reagent 10 is a buffer solution which ensure the pH of the water is maintained within a range suitable for the titration. A specific pH level is often necessary for the indicator to work properly and give a clear color change. After that, add 5 drops of reagent 11L. Reagent 11L is a titrant or a complexing agent. This chemical binds to the calcium ions in the water sample. The purpose of adding reagent 11L is to titrate the calcium ions. As the titrant binds with the calcium ions, the color change process begins. And the last one is at reagent 12 until the color change from red to blue. Necessary safety precautions. First, use safety goggles to protect your eyes from splash. Second, wear gloves to avoid direct contact with any chemical like reagent 10 and reagent 12. Third, work in a well-ventilated area. These outcomes can help to understand the severity of high calcium levels in water by the first one is identification of hard water. The primary outcome is the observation of the color change. Reagent 12 will continue the reaction with the titrant. As reagent 12 reacts with reagent 11L, the color of the solution should change from red to blue. The color change from red to blue indicates that all of the calcium ions have reacted with the reagent 11L and the titration is complete. The second one is approach take for water treatment. Based on the test result, individual or parties involved may decide to take action such as installing water softeners or using descaling agents to reduce the impact of calcium on plumbing and equipment. A water softener or descaling agent reduces calcium level through ion exchange. It swaps calcium and magnesium ions that causing hardness with sodium ions. The water flows through a resin bed where the ions exchange, resulting in softer water.
One civil engineering solution to reduce the impact of high calcium level in water is purification using reverse osmosis technology. Reverse osmosis is water purification process that involves forcing water through a small particle but block others, like bigger particle, to remove dissolved salt, minerals, including calcium and other substances. The membrane allows only water molecule to pass through while blocking larger ions such as calcium, magnesium and other hardness causing mineral. There are several benefits of this reverse osmosis technology. The first one is effective calcium removal system can significantly reduce calcium concentration in water and producing softer water. The second one is this method not only remove calcium but also kill harmful pollutants, making the water safer and cleaner. The third one is reverse osmosis can be used for both drinking water purification and for massive industrial applications such as water supply for local use or cooling system. The last one is, while initial costs for the system can be high, they are effective at reducing calcium and other dissolved solid in the long run. The conclusion of this process is reverse osmosis is widely used in areas where water sources have high mineral content and where high quality, low mineral water is required for industrial process or for human consumption.